All right, let's get into it. For anyone working in the electrical industry across Australia and New Zealand, you know there's one document that is the absolute bedrock for everything we do, the AS/NZS 3000. It's often called the wiring rules, but really, it's our industry Bible. And keeping up with the changes, well, it isn't just about ticking a compliance box. It's about safety, it's about innovation, and it's about being a true professional. So today, we're going to decode the key updates in the 2018 edition and really dig into what they mean for you, out on the job. To really get a handle on where we are now, you've got to look back at where we've come from. The wiring rules aren't some static, dusty document on a shelf. No, it's a living, breathing standard that's been evolving since way back in 1931. Just looking at the visual history here, you can see how much it's had to adapt over the years to new tech, new ways of working, and just the demands of our modern world. It's a legacy of safety built up over almost 100 years. So here's how we're going to break it all down in this explainer. First, we'll look at how the whole philosophy behind the rules has changed over time. Then we'll get into the brand new two-part structure, which is a huge deal. After that, we'll dive into the critical safety upgrades. Then we'll touch on how the standard is keeping up with modern technology. And finally, we'll see how these rules play out in a really demanding, real-world setting to bring it all together. Okay, so let's jump right into Section 1. To truly grasp the 2018 update, you have to understand the journey the wiring rules have been on. For decades, there's been this sort of tug of war between giving electricians really specific step-by-step instructions versus empowering them with core principles to solve problems on their own. This timeline, it tells a really fascinating story. Back in 1931, the first edition was super prescriptive, basically a straightforward how-to manual. Then, fast forward to the year 2000, the industry felt that was way too restrictive, so there was a major shift to an outcome-based standard. It focused more on the why than the how. But that turned out to be a bit too vague for a lot of people. So, based on a ton of industry feedback, the 2007 edition brought back a lot of that prescriptive detail. And that brings us to 2018, which is really the best of both worlds, a refined hybrid that strikes a fantastic balance between those foundational principles and clear, actionable rules. So, all that back and forth, that whole evolution in thinking, it led directly to the single most fundamental change in the 2018 edition, its structure. The standard is now split into two very distinct parts, and each one has a very specific job. Getting your head around this two-part philosophy is absolutely crucial for using the document correctly. So here's the split. Think of it this way. Part 1 is your foundation. It's the why. It lays out the core safety principles that everything else is built on. You're going to turn to Part 1 when you hit a weird situation, maybe a totally new kind of installation or a new technology that isn't spelled out in the rules. Part 2, on the other hand, is the how-to. This is your day-in, day-out rulebook. It has all the specific prescriptive instructions that are deemed to comply. And the standard is crystal clear. If you follow Part 2 to the letter, your work is compliant. Simple as that. All right, we've got the structure down. Now, let's get into the stuff that really matters on the job site. Section 3 is all about the major safety upgrades. These are the changes designed to seriously raise the bar for protection, and let's be honest, to save lives. First up, let's talk about RCDs, residual current devices. Before we jump into the changes, let's just do a quick refresher. An RCD is a life-saving device. It's constantly monitoring the circuit, and if it detects even a tiny amount of current going where it shouldn't, like through a person, it shuts the power off almost instantly. So, the big change in 2018 is a massive expansion of where RCDs are needed. In residential work, RCD protection is now mandatory on all final subcircuits. And we're not just talking about your regular socket outlets anymore. This now includes hardwired gear like ovens, air conditioners, hot water systems, you name it. The goal is simple. Drive down the number of electric shock fatalities even further. Now, the trade-off here is the potential for more nuisance tripping, which can be a real headache to diagnose, especially with older appliances. And the exceptions to the rule? They're now incredibly rare, basically limited to critical life support equipment, like a home dialysis machine, where an unexpected trip could be more dangerous than the shock risk itself. Now, let's switch gears to another critical safety device. And this one's a new player in the wiring rules, the arc fault detection device, or AFDD. Here's the key difference. While an RCD protects people from shock, an AFDD is designed to prevent fires. It's a smart device that can actually detect the unique electrical noise of a dangerous arc fault, which is a major cause of electrical fires, and it cuts the power before that arc can start a blaze. AFDDs are a really significant, proactive step forward in fire prevention. The technology's been around for about 20 years, getting better and better, and putting it in the standard is a direct response to the ongoing risk of electrical fires. Now, this is super important. The specific rules for AFDDs are different for Australia and New Zealand, so you absolutely have to check your local clauses. Generally, they're recommended for high-risk circuits, like in places with sleeping accommodation, areas with flammable materials, or buildings with old, sketchy wiring. As we all know, the electrical world is changing at a crazy pace. So this next section is all about how the 2018 wiring rules have been updated to tackle new technologies and just the realities of our more connected, more electrified world. Here are a few great examples of how the standard is getting with the times. First up, electric vehicles. They're everywhere now, so a definition has finally been added to help standardize the rules for their big onboard batteries and charging systems. Second, lifts. The rules have been updated for modern high-rises. Emergency lifts are now treated as essential safety services because, trying to get down 20 flights of stairs in a fire just isn't realistic or safe. In a nod to our globalized world, certain foreign socket outlets are now allowed, a practical fix for international hotels and airports. And finally, with the solar boom, there's new guidance for rooftop PV wiring to make sure the enclosures don't block rainwater and cause leaks. Okay, we've covered the history, the new structure, and the key updates. But how does this all actually come together out in the field? Our final section here is going to bridge that gap between the rulebook and reality by looking at how these standards get applied in a complex, high-stakes industrial setting. So, when the stakes are really high, how are these rules actually put into practice? Let's check out a specific case study to see how a major organization takes the ASS/NZS 3000 as its foundation and then builds on top of it. Check this out. This table from South Gippsland Water's electrical spec is a perfect real-world example. For their switchboards, they demand a specific type of separation for big motors to contain faults, which comes from another standard referenced by the wiring rules. For earthing, their rule for less than 10 ohms resistance is a direct application of Section 5. But then look at the cabling. They require 30% spare capacity on all circuits for the future. That goes way beyond the minimums. This shows you exactly how it works. The standard is the floor, the absolute baseline. Serious organizations then build their own higher standards on top of it. There's a quote from the documentation that just nails this whole philosophy of building in quality from day one. It says, "Start right, stay right," is the only way. You can't just slap on compliance at the end. It has to be designed and built in from the very beginning of any project. And that really brings us to a final, forward-looking thought. The wiring rules are always evolving. In fact, work is already underway on the next amendments. So, as our world gets more and more electrified, with smart homes, with massive renewable energy projects, with EVs becoming the norm, the big question we should all be thinking about is this: what is the next frontier for electrical safety? What new challenges will the next edition of the rules have to solve? Thank you so much for watching this deep dive into the AS/NZS 3000 2018 update. We really hope it's given you some clarity and some valuable insights you can take to your work. For more expert explainers on the topics that matter in your industry, please be sure to like, share, and subscribe to our channel. And feel free to explore for more videos. Until next time, stay safe out there and stay compliant.